So continuing log laws. So index law 2, a to the m divided by a to the n. Someone's talking. So as was very sensibly pointed out, log law 2 is the exact same reverse of index law 2. Log of x over y is log a x minus log a y. So thinking about these in both ways, if I've got log of base a to x minus log base a y, I will divide. Like the index laws, these do work both ways. So this is log law 2, and it goes with index law 2. So for an example, log a 22 minus log a 11. We see I'm subtracting logs of the same base, so that will be a log of that base dividing these. 22 over 11, that is log a 2. An example where we simplify and evaluate. Log 2 6 minus log 2 3. Now if you think about it, 2 to the power of what gives me 6? Is there a whole number answer for this one? No. 2 to the power of what gives me 3? Is there a whole number answer for that one? No. So we look at those separately and I go, I can't work this out, I can't work this out, my life is ruined, I will fail this test. But we see we're subtracting 2 logs of the same base. We rewrite log to that base and a division. Oops, that's 6. I'm getting ahead of myself. Over 3. So that's log base 2. 6 divided by 3 is 2. 2 to the power of what gives me 2? 1. Often, we can't easily evaluate the 2 separate parts, but using the log law means it's actually dead easy.
So it's going to be like 2 to the power of 2.5 and 2 to the power of 1.5 sort of thing, roughly, and then it'll be like, that's why it's 1.
Well, we could work out log base 2 6 if we wanted.
Which would get it.
But at the moment we'd have to do that by trial and error with our calculator, and that would be annoying.
Yeah.
Tomorrow we'll learn how to work out log 2 6 with a calculator. People, but to do that we need the log laws, and to do that people need to stop talking. So that's log law 2, it goes with index law 2. Guess what log law 3 goes with? So, shh, people, index law 3, a to the m, in brackets, raised to the n, we multiply a to the mn. Log law 3 log base a of x to the n is n times log base ax. So it was raised to a power, and it's times. It was raised to a power, and it's times. This one we're going to need to be able to do both ways very fluently. If I see that there's a power here, I need to be able to bring it to the front. If I see there's a number in the front here, often I'll want to bring it over here so it's a power. proving this one and proving index law 2 are pretty useful, yes.
Can you add brackets?
Where?
So, after the end.
Here?
Yeah.
No. There's an invisible times sign if you want it.
Where did M go? Where did M?
This, in the index law,
It's a different.
totally different law, it's just the law it's related to. Remember, power over power. Here I've pretty much got power over power. Power, it's there. Look, if you want to follow through the working of this is how we prove this, we can, and we can track through where everything goes. But you saw how long it took to follow through the working of the first proof. We do one proof in class. If you want to do the other proofs, it's a great exercise. I will happily do it with you, but not in my time. So examples of this one. Oh, I should put my log law in a little box so that we're all important. There we go. So we're simplifying 3 log A2. So see, this is in this form. If they ask me to simplify, I know that 3 times a log, I can move that 3 times the log and make it a power. In the same way that when I see a power in the index law, I know I can make it times. So it's reverse. So this is log base A 2 to the power 3. That's log base A 2 to the power 3 is 8. So it's a more simple log like that. I've got fewer numbers, it's good. So, so those are the 3 log laws that we use.
Is there a way to give an example, how to explain how the third log law works?
If you want to explain how it works,
So far it's just been move something somewhere which isn't really...
yeah, because you've got to follow the proof, or there's not much point. Once I've gone through the next ones, we'll do an example with nice easy numbers.
Yep.
Okay. Along with the log laws, coming from those 3, we have these properties. And each of these matches an index law as well. Log base A 1, any base to a particular power giving me a result of 1, what is that particular power? 0. Because that comes from the index law, A to the 0 equals 1.
Could be 1 to the power of 1.
Yeah, don't get into that because that's our undefined. So going along with that, log base A to the power of what gives me A? Anything to the power of what gives me itself? 1. And that's from the index law, A to the power of 1 equals A. So we're just rewriting the index law in log form. A to the power of 0 equals 1, so log base A1 is 0. We're just rewriting index laws as logs. That's all we're doing this whole lesson. And this one comes from log law 3. Okay, log base A to 1 over x. How can I rewrite 1 over x? Index laws. So this is log base A x to the negative 1. And log law 3 says how can I rewrite when I've got a power of x? Put it to the front. So negative 1 is just negative log base AX. So this one comes from log law 3. And from 1 over x equals x to the negative 1 in index form. So there's always an index law relationship to each of our log laws because log is inverse of index. They are completely intertwined. So let's simplify and evaluate. All right, 3 to start with. Try to keep my log properties in view. Log 2, 1 says 2 to the power what is 1? It must be? 0. And that is because log base A1 is 0. So you can put a little reason in. Log base 5 is? 1 because log AA is always 1 because of the index law. 2 different approaches for solving this one. Log of the base with a fraction. We've got this. Now we can use this result or this result. Either of these will help us simplify this and evaluate, and I'm happy to do them both. So if I'm going for this would be rewritten as log of base 6 is 36 to the negative 1. And I can write 36 log base 6 as 6 squared to the negative 1. So see how I'm going back to using my index laws, yeah?
So, like, would you want to do that if it was a fraction like that, or could you leave it at the front?
Leave what at the front? Okay. Working through using this value. So, 6 to the power 2 to the power negative 1. Log base 6. 6 squared to the negative 1. What do I do with the powers? Multiply. So this is 6 to the... like that. And really recognize this pattern because this is saying 6 to what power gives me 6 to the negative 2? It's a trick question. What power?
0.
Negative 2. 6 to what power gives me 6 to the negative 2? Trick question. It's negative 2.
So you just cancel the 6s out pretty much.
When you see that, yeah. It's like when you say 5, the square root of 5 squared. It's given you your answer of 5. The other way of doing this, if you wanted, is to take it all the way to there. Negative log a to the x. So this could be written as negative log 6, 36. And I've got a negative in there. 6 to the power what gives me 36? 2. So you'll see there's times when you probably want to use this form of the rule here, but sometimes a negative power is kind of useful to us. Either of those sets of working is fine. So, you have to know the log laws, the 3 log laws and those 3 log properties. They match in with the index laws, so that's your way of remembering them. And you have to have done all the work.